In this video, we're going to go through some extra examples involving Venn diagrams. So we're first going to shade the appropriate region. So we're going to practice shading, but we need to label our sets first. So they want us to shade A union B complement first. So that means our sets are A and B. Okay, it doesn't matter how you label, but now we want to do some shading. So when we do the union, it means that you're in A or you're not in B or both. So that means being in A is enough to be in this set. Okay, so we can shade all of A. And then being not in B is also enough to be in this set. So anything outside of B, so that just adds the outside bit here, also means that you're in A union B complement. So we're going to shade everything except that one side of B. So that would be A union B complement. Okay, now again, we have sets A and B. So now we want to shade A complement intersect B complement. So here, you have to be not in A and not in B. Okay, so we want to shade the area that contains elements that are not in A and not in B. So they have to be outside of the A circle and also outside of the B circle. So this is just the outside region of this diagram. So we shade all the outside. Maybe I'll just write over here what I said before. So this one is you're in A or not in B. And remember, or includes or both. Okay, let's try some 3 circle ones. So I'm going to label the sets. So let's call them A, B, and C. So now I want to shade the area. So this is not in A, so we're in A complement, and we're not in B because we're in B complement, and because I'm intersecting, we're in C. Okay, so in C means that we have to be in the C circle. Okay, so we're in the C circle here, but we're not in A, so we're outside of this part, and we're not in B, so we're outside of this part. So the only bit we're going to shade is this outer portion of C that does not intersect A or B. Okay, let's try another one. So here we want A union B intersect C complement. Okay, so let's write out what that means. So we want elements that are in A union B and not in C because of the intersection. So we know that we're going to be outside the C circle, so nothing in there is going to be shaded. And then we have to be in A union B. So remember, A union B is all of those 2 circles. Okay, so we have to be in there, but outside of C. So we're just going to be in these 3 spots here. Okay, so that's what I'm going to shade. So we're in A or B, and we're not in C. Okay, let's try something else. So here we have to label the shaded region. So this is a bit harder generally. So you want to try to describe the elements. So in the first example here, so these elements are in the A circle and they're not in the B circle. So what that set is going to be is, oops, I want to make it bigger. So A intersect B complement is the shaded set there. Okay, now what about the next one? So everything outside of A is shaded. So we're going to include all elements that are not in A. This is actually just a complement. So we don't have to always include B in our answer or all the sets. So we could describe this by saying we're just outside of A. Now I want to just mention that there's multiple ways to describe these sets, so I'm just giving one example, the most common example. This is the most simplified way you could describe these sets. Okay, some 3 circle sets. So if we look at this shaded region, we see that it's in the intersection of A and C. So here's A and C. So it is the intersection of A and C. And it could intersect with B, and it could not. So that means we could describe it by just saying A intersects C. Okay, so it's in A and C. All these elements are in A and C, and they may or may not be in B, so we don't have to write B. So this means, so these elements are in A and they're in C, and they may or may not be in B, which is exactly what we want. Okay, one more. So here, these elements are all in the circle A. So we see that they're all in A, but there's 3 spots for them. So if it was just these 2 spots, we would say it's A intersect B. If it was just these 2 spots, we would say it's A intersect C. And what happens if I take B or C? So that's all of that. So A intersect B union C is actually going to be all 3 of these spots. So that's how we can describe this one. So it's A intersect, and now we need brackets here, so I want to do B union C first. So compute B union C, that's going to give you these regions here, all of them. And then when I intersect that with A, I just get these 3 spots. So labeling can be hard. In our class, it's more important to be able to read from the diagram than it is to label the diagram. But if you can do both, then that's as good as you can get. So let's try another example. So suppose a group of applicants for training as air traffic controllers consists of 35 pilots. So I'm going to start writing this down. So the number of pilots, I'm going to call that P, is 35. The number of veterans, so I'll call that V, is 20. 30 pilots who were not veterans, so that means that they are pilots and they're not veterans, so they're in V complement. That's 30. And 50 applicants were neither pilots nor veterans, so the number who were not pilots and were not veterans is 50. And what they're asking us to find is how many applicants did they have. So that's going to be the number in the universe. So they want us to know how many applicants they have. So again, you don't have to use a Venn diagram probably, but I think it's the easiest if you do. So this Venn diagram is going to have 2 circles. Okay, so one for pilots and one for veterans. Now you might notice that they did not give us the middle. Okay, I don't know how many applicants were both pilots and veterans. Okay, but there are some things that I do know. So we know how many applicants were not pilots and not veterans. So that area of our Venn diagram is outside of both circles. So we know this outside bit, so outside of these circles, we know that there's going to be 50 applicants. Okay, so that's that one. That's where that goes. We also have the space, the number of pilots, the number of applicants who were pilots and not veterans. So that means that they're in the P circle, but they're outside of the V circle. So that's this spot here. So we know that this one is 30. And I'll highlight that in yellow so you know that that is that exact spot. Now we can figure out the middle quite easily. So we know that the P circle adds to 35. So there's 30 people on this side, which means there has to be 5 people on this side. So this remaining spot is going to be 35 minus 30. So 5. There's 5 applicants that were both pilots and veterans. And then we know the V circle here adds to 20. So on this last spot, it has to be 20 minus the 5 that are in the middle. So that's 15. And now we can compute the number in the universe by simply adding up all these spots. So it's 30 plus 5 plus 15 plus 50. So if you add that, you get 100 different applicants. Okay, let's try a 3-circle Venn diagram. So we conducted a survey of elementary school class with 35 students. Okay, so the number of students is the number in our universe. So I know there's 35. And we asked them about the fortnight dances that they know. So 28 students knew the dab dance. So I'm going to call that D. So the number that knew D is 28. 17 students knew the electro swing dance. So I'm going to call that E. So the number in E is 17. 26 knew the floss. So that can be F. So the N of F is 26. 20 students knew both dab and floss. So D intersect F is 20. 15 knew dab and electro swing. So the number in D intersect E is 15. 14 knew electro swing and floss. So the number in E and F is 14. And 12 knew all 3. So the number in D intersect E intersect F is 12. So let's make our Venn diagram. Okay, so here we go. I'm going to call this D, E, and F. So we know that there's 12 students that are in the middle that know all 3 dances. Okay, now the number that know E and F is 14. So E and F are these 2 regions here. So they have to add to 14, which means that this one that's left over has to be 14 minus 12, or 2. Okay, similarly, D and E are these 2 spots here. So those have to be 15, which means that the leftover spot is 15 minus 12, or 3. Okay, so D and F are these 2 spots. So that's 20. So this has to be 20 minus 12, or 8. Now, I'll use my last color here. So F is this whole circle. Okay, so that whole circle adds to 26. So that means the leftover bit has to be 26 minus 8 minus 12 minus 2. So that's going to be 4. Okay, similarly, E, the leftover bit, is going to be 17 minus 3 minus 12 minus 2. So that's actually 0. There's no students that only knew the electro swing dance. The dab, we have 28 minus 3 minus 8 minus 12. So that's going to be 5. And then to find the outside, we want to take our whole 35 and subtract each of these numbers. So 5, 3, 12, 8, 4, and 2, 0 if you want. If you do that, I think you get 1 student out there who didn't know any. Now we can use this to answer the following parts. So how many students knew exactly 2 dances? And the number that knew exactly 2 is, so these spots here are the ones that know exactly 2 dances. Okay, so this is going to be 8 plus 3 plus 2. So we're going to get 13 students. Now just to emphasize, the 8 is only D and F. Okay, the 3 is only D and E. And the 2 is only E and F, and not the third one. So we don't want to include the middle bit, because it doesn't say at least 2 of the dances, it says exactly 2 of the dances. Okay, how many students knew how to dab or floss, okay, or both, but not the electric swing? So this is the number, so they can dab or they can floss, that's the union, but they definitely don't know the electric swing. So in notation, that would be D union F and E complement. Okay, if you don't know the notation, you can still read this from the diagram. So they're outside of E, okay, so they're not in this circle here. Okay, but they do know how to either dab or floss. So they could maybe only know how to dab. They know how to dab and floss, but not electric swing. Or they know only the floss. So it's going to be those 3 spots there. So this is going to be 5 plus 8 plus 4. So 17 students in this category. Okay, let's try a harder one. So this is as hard as it could get. So I'm going to start by writing the information down like I did last time. Suppose 75 undergrad students were surveyed about how they take their coffee. Okay, so we know the universe because that's the size of the survey. So 75 people were surveyed. 22 like cream in their coffee. So I'm going to call cream C. So 22 like cream. 26 like sugar. So I guess I'll call that S. So that's 26. And 40 like Baileys in their coffee. These days, I think more people are doing that. So I'm going to call that B, and that's 40. 7 students like cream and sugar. So that's C intersect S is 7. 7 students like sugar and Baileys, but not cream. Okay, so that's pretty specific. So they like sugar, they're in S, and they're in B because they like Baileys, but they don't like cream. So that's C complement. So that's also 7. 10 like cream and Baileys. So that's C and B. Intersect B is 10. 54 like sugar or Baileys, or possibly both. So that's C union B is 54. And 11 like their coffee black. So that's no cream, no sugar, no Baileys. So cream complement, intersect S complement, intersect B complement. That was 11. And we want to know, so maybe I'll write here, want the number that like only cream. So in notation, that's C and not B and not S is what we're looking for. So let's make our diagram. Now the hard part about this one is that they did not give us the middle. Okay, so let's make this cream, sugar, Baileys. Now, they didn't give us the middle, so what I'm going to do, I want to start there, so I'm going to call this X. Okay, well actually before I do that, let's see, they did give us some exact spots. So let's think about which ones they are. Okay, so they like their coffee black. Okay, that is an exact spot. That means that you're outside all 3 of these circles. You don't take cream, you don't take sugar, and you don't take Baileys. So this outside bit is actually 11. Okay, we already know that because of that statement. Okay, now this other one is also very specific. So they take sugar and they take Bailey's, but they don't take cream. Okay, so we're in the sugar circle and we're in the Bailey's circle. Okay, so that means that we're in these two regions here, but we don't take cream. So that 7 goes in that spot exactly. Okay, so that's going to be 7. I'm going to highlight it yellow so that we know it's that exact spot. Okay, now nothing else is an exact spot. They all require more than one spot. So again, we want to start in the middle, so I'm going to call this X. Now they gave me, I'm going to leave this one for now because S union B, so sugar or Bailey's, is all of these spots. And you see that we're missing lots of them. So we probably want to look at that one later. So cream and Bailey's, those are these two spots here. So one of them is called X. So I can write the other one as 10 minus X. Then if I add those together, I get 10. Okay, so we put that one on. We put these two on already. Now cream and sugar, that's these two. So that's 7. So this has to be 7 minus X. So we did that one. Okay, now let's keep going up here. So if I look at the number in B, so that is the B circle, and everything other than this spot has something. So we can use the same idea we did here. So this is going to be 40 minus all these other spots. Now be careful that you put brackets in. Okay, so I need to do 40 minus 10 minus X minus 7. If I simplify, this is 40 minus 10 plus X minus 7 plus X minus X is actually 0 X's. So I end up with no X's here. And it's going to be 40 minus 17, which is 23. Okay, so we did that one. The number in sugar, so that's this circle. Again, we're only missing one spot. So we're going to take the 26 that are in that circle, subtract all the other things. So 26 minus 7 minus X minus 7. So this is 26 minus 7 plus X minus 7. So again, plus X minus X cancel out. And I have 26 minus 14. So I get 12 in total. Okay, so that's that one. So now the number in cream, so that's this circle. Again, we only have one spot missing. So we're going to take the 22 and subtract everything that's already in this circle. So minus 7 minus X minus 10 minus X. So this is 22 minus 7 plus X minus 10 plus X. So we get some canceling, so plus X minus X go away. But unfortunately, we still have an X left over. So it's 22 minus 17, which is 5, and then I have a plus X. And now remember that what we actually wanted was the number that like only cream. That is actually this spot. Okay, so that's what we're looking for. But it has an X in it. So we need to solve for X. Okay, now we did this already. So we have two things that we haven't used. Okay, the number in the universe and also the number in the union, S union B. So these are, either of these things are good things to try to solve for X. So if you use the union, you would add up everything that's in the diagram and equal it to 75. Now, a short inspections tells me that I have a plus X, a minus X, a plus X, and a minus X. So I have an equal number of positive X's as I do negative X's, which means that if I use this one, the X's are going to cancel out. So I won't be able to solve for X. If I use the union though, S union B, I'm just looking at this area here. So notice I have a minus x, and a positive x. So not the same number. So I think that this is the one that we want to use. So let's go down here. So the number in S union B equaling 54 means that 54 should equal the sum of everything in S or B. So that's going to be 7 minus x plus 12 plus 10 minus x plus 7 plus 23. I didn't really need the brackets there, but I wanted to emphasize the spaces I was adding. Okay, so that means 54 is equal to, so let's just expand all this out. So I'll put all the numbers together. So 7 plus 12 plus 10 plus 7 plus 23. And then I have a minus x, and a plus x. Okay, so some of these x's go away and I'm just left with a minus x. And when I add up all these numbers, I think I get 59. So I have 54 is equal to 59 minus x. So if I want to solve for x, I could add x to both sides. And, well, I'll just do one step at a time. So 54 plus x equals 59. And then I subtract 54 on both sides. So I have x is equal to 59 minus 54, which is 5, which you maybe could have got earlier without doing all that work. Now, be careful, because we're not done. Remember that the spot that we wanted was x plus 5. So now we found x, so we know it's going to be 5 plus 5, or 10. Okay, so there are 10 people who like only cream in their coffee. So that is as difficult as you might see when they don't give you the middle and they give you a bunch of sort of weird, more unusual sets. It can be hard to fill in, but you just want to be careful. Try and place ones that are basic regions right away. And then if they don't give you the middle, I tend to call it X and continue on. So hopefully that makes sense. Those are some basic examples for Venn diagrams.